Hey everybody, my name is Mike Woodcock. I'm the general manager here at Azuria Water Solutions. Some of you guys may know me from my days at Portland Utilities Construction Company, where we were a pipe bursting contractor for approximately 30 years. Uh, Through our pipe bursting endeavors, we came across a situation where we needed to adapt a little bit, and that's where we came up with this process called close tolerance pipe slurification. CTPS has elements of several existing trenchless technologies. There's elements of horizontal directional drilling. There's elements of close tolerance horizontal directional drilling, elements of pipe bursting, and pipe reaming. There's a reamer, as you can see from the picture on the right, there's a reamer that's sized only a quarter-inch larger than the pipe that is being pulled in at the same time. So we're pulling in a product pipe while we're performing the reaming process. We're pumping in mud, and that reamer combines the pipe and the soil into a slurry that the new product pipe pushes into the next excavation. And that's where the advancement or the innovation comes in, and where we think the game changer is, because when we considered the idea in terms of asbestos cement pipe, uh, we began to realize, like, hey, we're pushing most of this material out of the ground. We calculated 98% of the slurry is removed from the ground. And when we apply that to the asbestos cement pipe world, uh, that's a game changer. So when it comes to asbestos cement pipe, the water and wastewater industry has been a little bit confused on what can and can't be done. Even though the EPA has been very clear and consistent on its stance that leaving friable asbestos containing material in the ground uh, is not acceptable. You can't create an inactive hazardous waste disposal site. The industry seems to be either ignoring that information or just unaware of that information. And we thought with our method that we have in the CTPS method, we would be able to have a clear uh, way to go forward if we could get the EPA to give us the alternative work practice. Because what every method needs is for the EPA to say, yes, we approve this and we give you this alternative work practice for you to go forward with, and be that makes it clear and concise for the owners and engineers to design projects based on that method. So up until this moment, the only methods that could be used to replace AC pipe in the same trench that was approved by the EPA was open cut replacement. There were other trenchless methods that could be used, like you could line it or you could slip line it. You could also move over and dig and lay a new pipe in a different trench. But the only way to replace it in the same trench was by open cut replacement. And the CTPS methods was going to change all of that. So we brought the EPA down to our site, and we met with them. We gave them our pitch on the 98% slurry removal, removing 98% of the asbestos containing material. Uh, they asked us if the slurry would end up getting hard, to which we answered yes. And they said, well, okay, we can approve that because that means anything that's left in the ground would then also be encapsulated in that hard material. So the EPA worked with us, and together we formulated a proposal to which they approved. They called it an alternative work practice. So we have an approval from the EPA for a method that trenchlessly removes AC pipe in the same trench. And now engineers and owners can confidently uh, specify or allow AC pipe to be removed by the CTPS method, knowing that it meets EPA requirements. So now we have an EPA approved alternative work practice that says if you do CTPS, that's equivalent to as if you'd open cut and removed the asbestos from the trench. That's a game changer. Now we can confidently bring a method to the industry that replaces an AC pipe and leaves a situation where it's the same as if it was open cut and the hazard is completely removed. Now we can bring all the benefits and all the advantages of trenchless technology to the asbestos pipe replacement world. And heretofore, could not be done in a way that was approved by the EPA. A lot of people still think about pipe bursting, but the EPA considers that if you pipe bursted AC pipe, you've left an inactive hazardous waste disposal site that will not meet NASTT or EPA requirements. So the CTPS method, being able to do it to the standards that meet NASTT requirements and has EPA approval, totally changes the competitive position of how to replace AC pipe and do it trenchlessly. So we see this method as being a game changer. We're going to remove 98% of the asbestos-containing material. Anything that's left in the ground is going to be considered encapsulated. The EPA will consider it the equivalent to as if we open cut the pipe and removed it. So we're going to leave a safe trench for the owners and engineers in the community after this process is completed. Meanwhile, people will be able to confidently know that they've met the EPA requirements and get the benefit of trenchless technology. So again, how the method works, we've got a reamer that's a quarter inch larger than the pipe that we're simultaneously pulling in. We're grinding up the soil, the mud, and the pipe into a slurry, and then the pipe pushes that into the next excavation where we vacuum excavate the material and haul it off to the landfill. CTPS is a game changer. We now have an EPA approved alternative work practice where we can bring all the benefits and advantages of trenchless technology to the asbestos cement pipe replacement world. This is going to change how people address the AC pipe in this industry. I'd like to thank you for your consideration. My information's on the bottom of the slide. Please do not hesitate to call if you have any questions or comments.